Okay, so I said we would do work solutions for each of these. And so let's just lay out our triangle. We've got A, B, and C. Now, if we want to show this thing's isosceles, we need to find the length. So length AB equals, and we're using our length formula, which remember says do the difference of the x-coordinate squared plus the difference of the y-coordinate squared. So we are doing minus 3 take away 2 all squared plus 3 take away 4 all squared. Working that out, that's 5 squared. That's 1 squared, so this becomes root 26. I'm not going to do any more works than that. I'm just going to leave it like that. Second thing we're going to do is find length BC. The length of that is 1 minus 2 all squared plus 4 minus 1 all squared. So that's 5, that's 1, so that is also root 26. Don't just stop there. Just because we've got two lengths the same doesn't mean we can stop. We need to show that the third one is different, because otherwise we'd have an equilateral triangle. So we do need to find length AC. I've done this question in advance, so I actually knew B was going to be, these two sides were going to be the same, which is why I drew it like that. But you might not have known that. Your diagram might have been wrong. But you can correct that at a later point. So AC, we have 1 take away minus 3 all squared, so that's 4 squared overall. And we have minus 1 take away 3 all squared, which is 4 squared. So we've got 16 plus 16, so that is root 32. It's nice when you're doing a question like this to give a statement at the end as AB equals BC, but not the same as AC, then triangle ABC is isosceles. So there's our statement. We've convinced ourselves we've got two sides the same, but the third is not. So we've got an isosceles triangle. Now, part 2 is probably the trickier part of this. We've got our A, B, and C. Now, I've drawn this dotted line, which is a line of symmetry. Now, that involves two things. If it's a line of symmetry, it must be at right angles to the base, and it must pass through the middle of the base. So we're essentially finding the perpendicular bisector of AC, or you could see it as being the median from B. Both of those are actually true in this case. At the moment, all we need to know is the gradient of this line. So if we can find the gradient of AC and find the perpendicular gradient to that, then we have the gradient of this line here, which is the axis of symmetry. So we want the gradient of AC, so we're doing y2 minus y1 over x2 minus x1. That is minus 1 take away 3 over 1 take away minus 3. So that is minus 4 over 4, which is minus 1. Perpendicular gradient to that, this is negative, so the perpendicular gradient will be positive. And 1, so we go 1 over 1, or just 1. So the gradient of our line is 1. So that's your solution to question number 1. The gradient of the axis of symmetry is 1, and we've shown that it is isosceles. The next video will give you the work solution to question 2.